Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the two and you get 36. So it's going to be 36 newtons per centimetre squared. So we're asked to find angle BCE, and that is going to be this one here, because you start at B, go to C, and then go to E, and it's the angle you make. And I might just choose a different colour because we've already got red on here. So we're looking for this angle here. Now, my advice for these kind of questions is always just try and work your way around the shape with angles you know. So, for instance, I'm going to start with this angle here, and we're going to call this angle ADC. And we know that that must be 79 degrees. And always write down the reason, and we know it is because that is an isosceles triangle. So if you look, we've got an isosceles here, this one, and this one. And the bottom two angles, and I use the word bottom because I always imagine an isosceles as being this way up. The bottom two angles in an isosceles are always equal, so that must be 79. Now we've got two of the three angles in the triangle, and the last one is going to be angle DCA. And to work out what this angle is, we're going to take it away from 180. So we're going to do 180, take away the 279s we've just worked out. And the reason for that is angles in a triangle equal 180 degrees. Okay, so when we do that, we do 180, take away the 158, and we're left with 22 degrees. So we know that this is going to be 22 degrees. And now we can actually work out angle BCE, because it's going to equal angle DCA. And the reason for that is they are vertically opposite angles. So that's just going to equal 22 degrees. Now, it is really common for these types of questions for you to get maybe 1 or even 2 marks for the answer, but 1 or 2 marks normally for the reasons and for the explanations. In fact, I've seen quite a few exam questions where you get 2 marks for the reasons and only 1 mark for the answer. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table. And we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40. And we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80. And the frequency is how high it is, which is 10. The next midpoint is here. So that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability customer spent less than 160, so that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through two parallel lines, which are our two north lines, and therefore this angle here is going to equal this angle here. And the reason for that is that the two angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons, so that's because it's alternate angles, and we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B, and so to find this angle out, what we're going to do is just 360 take away 135, and the reason for that is angles on a point equal 360 degrees, and when we work that out we get the answer of 225. So our bearing is 225 degrees. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. To work out the area of a rectangle, we just multiply the width and the length. Here they are mixed numbers, so all we do is the width times the length. Now when you multiply with fractions, always make them top heavy first, or improper, and to do that you times the big number by the bottom and add it to the top. So we're going to do 1 times 2 and add it to the top, so 3 over 2. Same with this one, 1 times the 3 at the bottom added to the top. 1 times 3 is 3, add to the top is 5. Now we've got to get the numerator, we don't need to get the numerator the same, we're multiplying. All we do now, really easily, is just multiply the tops and multiply the bottoms. So we've got to convert 15 over 6 into a mixed number because it asks for a mixed number. So 15, how many 6's go into 15? Well, we're first of all going to have 2 whole ones, and how many left over? There are going to be 3 left over. Now, 3 over 6 is the same as 1/2 because we can divide top and bottom by 3. So our answer is 2.5. So let's just write out this sequence. So first thing we're going to do is work out what the sequence is going up in. And we can see here that we're adding 15 each time in our sequence. And whatever the sequence is going up in is what goes before n, so it's going to be 15n. Now 15n would give us the 15 times table, and this isn't the 15 times table. So to work out what the offset is, we go and find our 0th term. So instead of adding 15, when we go backwards, we're going to take away 15. And so that would be 10. And so our answer is going to be 15n, and we're going to add that 10 on. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually times it by not 1,000, but 1,000 squared, so that's another 3 zeros. You can see here that that's 1,000,000, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. The rules are that when you multiply two numbers with the same base, and the base is the big number, then all you need to do is add the powers. So we're going to do 6 to the power of 15 plus 4, which is going to be 6 to the power of 19. I'm just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile rainbow, and I put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So our answer is 35x plus 20. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. To answer this question, I'm going to do a quick number line, and I'm going to put the 12 meters on my number line, and I'm going to think what the next number down would be that it could have rounded to. Well, it's 10 to the nearest meter, so the next number it could have rounded to is 11. And to find the minimum it could have been before rounding to 12, all we need to do is find the halfway point between 11 and 12, which is obviously going to be 11.5. So our answer is 11.5 meters. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78, and we must write down the reason. So corresponding angles, and corresponding angles are equal. Now here we've got an equation, and we want to solve it, so we get our lines in. We'll go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180 angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So Pythagoras says that a squared plus b squared equals c squared, and the c is the one opposite the right angle. So I'm going to label this a and b, so it would be 5 squared plus 12 squared equals c squared, 25 plus 144 is equal to c squared, and then 25 plus 144 is 169. And then we're solving to find out what c is, and we're just going to square root both sides. So square root of 169 is 13. So c is 13. We can rewrite this question as 2 over 1 divided by 1 over 15. Basically, when you've got an integer, which we do here, a whole number with 2, you can just write it as a fraction of that whole number over 1. Next we do keep, flip, change. We keep that first fraction, 2 over 1, change that divide sign to a times, and flip the second fraction. Multiply the tops, multiply the bottoms, and 30 over 1 is just the same as 30. So our answer is 30. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got well, we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. What is it? 990. Now, when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. We're told here that y is proportional or inversely proportional to x, so we put 1 over x because it's inversely, and inversely means it's going to be proportional to 1 over. Going to replace that proportionality sign for an equals, and to do that we need to multiply the right hand side by k, so it becomes k over x. And we're told that x is 7.9 when y is 10.27, so we're just going to substitute those both in so that we can find out what k is, what our constant is. I'll do a bit of simple solving by multiplying both sides by 7.9. When I do that, I get that k is 10.4. Go rewrite our equation we wrote here, but this time with our k value in, which is 10.4. And we're asked to find out what y is when x is 8. So we just do 10.4 divided by 8. And when we do that, we get 1.3. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus. And the choices are male and female. And we've got our second kind of branch, I suppose. And it's still male and female. And this is our second bus. So the property of male on a first bus is 9 over 15. And therefore the property of female is 1 minus 9 over 15, which would be 6 over 15. Male on the second bus is 7 over 15. And so female would be 8 over 15, because they need to add up to 1. and it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6 over 15 and 8 over 15. The word and in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6 over 15 times 8 over 15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can times top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together, and I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16, and then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So when we're doing column vectors and adding and subtracting them, we just literally add and subtract the top and bottom numbers. So a plus b minus c will be, just looking at the top, 9 plus 18 minus 9, 9 plus 18 minus 9, which will equal 18. And the bottom will be 9 plus minus 18, so really minus 18, and minus 9. And so that will be minus 18. So our column vector will become 18 minus 18. So we need to first of all work out how many black and red counters there are at the start. Now if you look at the fraction of the probability of picking a black, in your first pick is 2 over 5, and then the second pick is 1 over 4. So you can see that there's one less at the numerator and then one less overall. So that means we can conclude that there are 2 blacks at the start, 2 black counters, and if there are 2 black counters and there's only black and red counters, then there must be 3 red counters, so that to make up the fact that it's 2 over 5. Okay, so to find the missing probabilities, the first couple are quite simple because we know that, let's do a different colour, this and this have to add up to 1. And so if the probability of picking a black there is 1/4, then the probability of picking a red must be 3 over 4, because these have to add up to 1. Same with these two, these have to add up to 1. So if we've got 2/5 at the top, the bottom one must be 3/5. And finally, we've got these two here. Now these two here we're not given any fractions for, but given the fact that we started with 2 black and 3 red, we've picked one of the red, so we've got one less red, and that means we've got 2 black counters and 2 red counters. So it means that the probability of picking a black is 2 over 4, or 1/2, and the probability of picking a red is 2 over 4, or 1/2. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. Acceleration is change in velocity over change in time. So change in velocity, where it starts at 0 and goes up to 150, so that would be 150, over the change in times. Well, the time starts at 0 and goes up to 5, so that's 5. And so 150 divided by 5 is 30. The velocity is in meters per second, the time's in seconds, so the units will be meters per second squared. So it's 30 meters per second squared. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the bottom, or the top one, tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So we're going to first of all realise that this is a right angle triangle and we've got two lengths and an angle involved, therefore it's going to be trigonometry. So we're going to just label the sides first. The one opposite right angle is the hypotenuse, opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have a number or a letter next to it, so it's not interesting, so get rid of that. Next we're going to do our trigonometry triangles. And so we've got SO, CA, TOA. And we are just crossed out the adjacent, so we don't need this one and we don't need this one. And we're going to end up with SO, which is short for sine the angle equals opposite over hypotenuse. The angle is marked as x, so sine x equals √3 over 2. You need to know from memory that sine 60 is √3 over 2. And notice here that the x therefore is going to equal 60. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. Again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is -2. And then the bottom will be 6, take away, -4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. The way you do this question is very, very similar to if it was 1/5 minus 1/6. You need to get the denominators to be the same, and then you add or subtract the tops. Well, be subtract in this instance. So 5 and 6, the lowest common multiple of 5 and 6 is 30, so I'm going to times the left hand side top and bottom by 6 and the right hand side top and bottom by 5. So times the top and bottom of the first one by 6, you get 6x over 30. Times the top and bottom of the second one by 5, you get 5x also over 30. And when you've got a common denominator, you just subtract the tops, so it will be x over 30. I'm going to first of all get x equal to the 0.151151 blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000 and we'll get 151.151.151 blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151.151, etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So there are two things with this question. There's the negative power and there's the half. And we're going to deal with them separately. So to deal with a negative power, all you need to do is put the whole thing over 1, or 1 over the whole thing, I should say. And it's nothing more complicated than that. We just copy the same thing again, but this time instead of it being negative a half, it's just to the power of a half. So that's dealt with the negative. Now to the power of a half means square root. So whenever you see anything to the power of a half, it just means square root. So let's deal with the 16 and the x to the power of 16 separately. Now with the 16, we're going to square root it, because to the power of a half just means square root. So square root of 16 is 4. Now with the x to the power of 16, there is another rule in indices that say if you've got a power on the inside and a power of the outside, you just multiply them together. So 16 times a half is 8. So the answer will be 1 over 4x to the power of 8. So the way functions work is that they actually queue up, and the function nearest the brackets is the first one to go. So the f will be the first function we look at. So all I'm going to do is just leave the g on the outside and just put a set of brackets down. So to do f of 4, all we do is we feed in that 4 into where x is in the function f of x. So instead of 5 times x, it will be 5 times 4. Which is just going to be 20. Now that's the f of x sorted, and we're now going to look at the g of x. The g of x says that it's going to be 3 plus 2 lots of whatever's fed in, and we're going to feed in that 20. So it's going to be 3 plus 2 times the number we're feeding in, which is 20. And 2 times 20 is 40, and then 3 plus 40 will be 43. So our answer will be 43. When you square root a fraction, you can actually just square root the top and square root the bottom. So square root of 9 is 3, square root of 16 is 4. So that is equivalent to 3 over 4. So 2 over 11 is the same as 2 divided by 11. And we can do that with a bus stop. So if I just do a bus stop down here. So we've got 11 on the outside and 2 on the inside, and chance I will almost certainly need decimals, so I'm just going to put some zeros in. 11 into 2 does not go, so we're going to move that 2 across. 11 into 20 does go 1 and carries the 9. 11 into 90 goes 8. and carries a 2. Hang on, 11 into 20 goes 1, carries the 9. We can see a pattern going on here. 8, carry the 2, and 1. So you can see that this is just going to keep going on forever. So 2 divided by 11 is 0. And the 1 and the 8 are just repeating forever. And the way we show that is with a dot above them. And so when comparing this to the bit in the question, our x value will be 1 and our y value will be the 8. We can see that there's a negative before the x inside the function for the graph which asked to draw. And what that will do is it will just reflect the graph in the y-axis. And so what we're going to do is we're going to just mirror this graph, and we can see it crosses the y-axis at 0, 2. And this is not the easiest one to draw, but we want it to kind of roughly reach the peak there. And then what's that, 2.5, so it'd be roughly there. And it will go off the graph about there. And it will reach the bottom about there. So we just want to roughly draw it out. And this is a kind of sketch because we can't be too accurate with this. And you wouldn't necessarily be expected to be perfectly accurate. But that's more than good enough to give you the mark. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that would be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. Now notice the format that it wants the answer does not have a square root at the bottom, so we are going to be rationalising the denominator with this. So I'm just going to write out the question, just so we've got a start. And notice here we've got this 6 plus root 2. Now you might think you rationalise the denominator by timesing top and bottom by root 2, and that would get rid of the root 2 there. But it would actually create a 6 root 2 at the bottom, so it won't rationalise the denominator. The trick here is, imagine that the bottom here is a bracket, and what you want to do is times top and bottom of this fraction by the same bracket, but with the different sign, the opposite sign in the middle. So instead of 6 plus root 2, it's going to be 6 minus root 2. So we're going to have 6 minus root 2. Okay? And when we do that, we can imagine that there's going to be brackets at the top as well. We've got 2 plus root 2 and 6 minus root 2 at the top. And then we've got the 6 plus root 2 and the 6 minus root 2. Now, the reason why we do that is you'll see when we expand the bottom one, but I'm going to start with expanding the top one. And it doesn't really matter which method you take to expand it. I'm just going to use the grid method because it's a little bit clearer maybe. And so we've got 2 plus root 2. And we've got 6 minus root 2. So 6 times 2 is going to be 12, and that's going to be 6 root 2 minus 2 root 2, and then that would be minus and a positive is a negative, and then root 2 times root 2 is just going to be 2. And so when we add these two together, we're going to get 10. When we add these two together, we're going to get plus 4 root 2. And I'm going to now do the bottom one. So this one was this expansion here, and I'm now going to do this expansion here, and we're going to do it down here. And so we've got 6 plus root 2 and 6 minus root 2. So 6 times 6 is 36, 6 times root 2 is 6 root 2, 6 times negative root 2 is just negative 6 root 2, and then we've got a minus and a positive make them negative, and then root 2 times root 2 is just minus 2. And so when we add them together, we've got the 36 and the minus 2 there, so that would be 34. And then 6 root 2, take away 6 root 2, is just going to be nothing. So that actually expands to be an integer, not a surd. And that's why we picked the opposite sign, is because whenever we do that, we get rid of the root 2, and we just get a nice number at the end. Okay, so when we put those in, and we end up with 10 plus 4 root 2 at the top, which is our answer here, over 34, which is our answer here. And let's just make that a bit nicer. There we are. And that's our answer down here. Now we're looking to see whether we can cancel at all, and if you look, we can actually divide everything by 2. So divide the bottom by 2 and we get 17. Divide the 10 by 2, we get 5, and we've got to divide all 3 terms by 2, so we get a 2 there. So we actually end up with 5 plus 2 root 2 over 17. So our missing numbers, looking back at the question, A would be the 5, B would be 2, and the C is 17. So the first thing to do is we want to find the roots from the sketch that we've got, and the roots are just where the graph crosses the x-axis. So we can see it crosses it here at -8, crosses it here at 3, crosses it here at 5. Now, what is special about roots? Well, roots are where the graph equals 0. It's where y is 0. And the only way to get to 0 is, for looking at this, is if one of these brackets is 0. So we're going to say, okay, well, let's have a look at the first one, x plus a. Let's get that equal to 0. Oh, equal to 0. So we're going to put in the first root in there. We're going to say -8 plus a equals 0. Add 8 both sides. A must equal 8. So if a equals 8, then the whole thing will equal 0. That's the first root done. Go do the same with the next one. X plus b equals 0. And this time the root is 3. So it's going to be 3 plus b equals 0. Take away 3 both sides, and you get b is -3. Then we're looking at the last one, x plus c. Look at the last root, which is 5. Oh, we're going to get it equal to 0, and then it's going to be 5 plus c equals 0. And take away 5 both sides, you get -5. And so if a is 8, b is -3, and c is -5, it means that at -8, 3, and 5, it will equal 0, which is what it does in our graph. Now you might say, well, why does a have to equal 8? Why can't b equal 8? It can. These can be in any order. And so if I wrote these in the opposite order, -5, 8, and -3, for instance, it would still be correct. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1, -1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.